Throughout the Mesozoic era, the dinosaurs coexisted with a number of reptiles related to crocodilians called Crocodylomorphs. Among these was Armadillosuchus, whose name means Armadillo Crocodile. This name is appropriate, as not only did this prehistoric crocodylomorph live entirely on land, but it famously possessed extensive body armor. However, unlike the images that circulate online, the visual similarities between Armadillosuchus and its namesake are often overstated, as the majority of art depicting it is as much fiction as fact. This is unfortunate, as the armadillo croc is one of the go-to examples of Crocodylomorpha's former diversity. This video aims to correct this common misconception, and to help more people learn about the real Armadillosuchus. Armadillosuchus was discovered in Brazil during 2005 and named in 2009. Its fossils are found in the Adamantia Formation, which is part of the larger Bauru group. The creatures whose remains are found here lived at the end of the Late Cretaceous period, near the climax of the Age of Reptiles. As in the rest of the world, dinosaurs were the dominant megafauna, with the belosaurid theropods serving as the most common top predators, while long-necked sauropods were the primary large herbivores. However, Armadillosuchus's branch of Crocodylomorpha, Notosuchia, had replaced many of the smaller dinosaurs in the southern hemisphere, and their fossils are particularly abundant in the Adamantia Formation. Unlike crocodilians, the Notosuchians were almost universally terrestrial. They were also incredibly diverse, including small plant eaters such as Caipirasuchus, medium-sized predators such as Baurusuchus, and even a few amphibious crocodile mimics such as Apoidesuchus. Within Notosuchia, Armadillosuchus belonged to the subclade Sphagosauridae. At over 2 meters long, Armadillosuchus was one of the largest sphagosaurids. Indeed, few terrestrial reptiles besides dinosaurs reached that size during the Cretaceous period. Its closest two relatives were Carianosuchus and Sphagosaurus, who were likewise large, at least by the standards of most land crocs. The rest of the sphagosaurids, such as Adamantiasuchus, were smaller, more gracile animals built for speed rather than power. The most important Armadillosuchus specimen consists of the front half of an articulated skeleton. It is the holotype of the only currently recognized species of Armadillosuchus, Armadillosuchus arrudii, which was named in honor of the Brazilian paleontologist J. Tadeu Arruda. The other two specimens are more fragmentary. One differs from the holotype in some key ways, and is thought to belong to a second species of Armadillosuchus, but is currently too fragmentary to serve as a holotype for a new species. Still, between the different specimens, most of Armadillosuchus's body is accounted for, with the exception of the hind limbs and tail. Armadillosuchus's namesake armor was made up of osteoderms, bony plates within the skin. Osteoderms are also what makes up the armor of both crocodilians and armadillos. As mentioned before, there is a misconception that the armadillo croc's armor was nearly identical to that of actual armadillos. The source of this misunderstanding is a skeletal model of an Armadillosuchus on display at the Museum of Environment in Rio de Janeiro. The small gaps in the model's armor give the impression to onlookers that it is a real, nearly complete skeleton of Armadillosuchus, or at least a cast based on such a specimen. However, most of it is not just mere speculation, but outright fantasy that contradicts the actual fossil material, which happens to sit right next to it. Unlike armadillos, there are 2 rows of non-interlocking plate-like osteoderms along the back. Called paramedian osteoderms, they were common among crocodylomorphs and their relatives, and were present on the real Armadillosuchus. Another difference from armadillos in the model skeleton is that its armor is not divided into bands, which are what give armadillos their flexibility. Instead, most of the armor is reconstructed as a single, rigid shell broken only by the paramedian osteoderms. This invokes not modern armadillos, but the larger, extinct glyphodonts. For this, the inaccurate model and its derivatives are nicknamed the taco shell reconstruction. In the real Armadillosuchus, only the osteoderms just behind the head, which are called the cervical shield, formed a rigid plate. It seems that whoever made the model extrapolated this pattern to the rest of the body, even though what is preserved in the neighboring holotype is very different. Strangely, there is another reconstruction of Armadillosuchus at the same museum whose armor is much more accurate. Each of the paramedian osteoderms were surrounded by a row of smaller, round osteoderms embedded in the skin. These rows were organized into straight lines, as opposed to the more random placement of the osteoderms of the cervical shield. They were more tightly bound together than the armor of crocodilians or other notosuchians, with the primary point of fixation being between the rows, which reminded the paleontologist when she described Armadillosuchus of the mobile bands of armadillos, hence the name. That these rows are absent in the taco-shelled reconstruction, despite being its namesake, makes the situation all the more perplexing. In an apparent attempt to reconcile the contradictions, this illustration instead divides Armadillosuchus' armor into segments. The artist appears to have been under the impression that the cervical shield was typical of its armor, like in the taco-shelled reconstruction, but also that the divide between it and the rest of the armor is what the bands mentioned in the description refer to. In the real armadillo croc, there was still some degree of flexation possible within its bands, and there would have also been plenty of scales visible between the osteoderms. In an interesting twist, the banded armor may have been absent in the back half of the armadillo croc's torso. Although not all the armor is preserved in the holotype, the furthermost preserved paramedian osteoderms lack the accompanying rows of smaller osteoderms. Therefore, Armadillosuchus may not have been as heavily armored as is commonly thought, taco shell or not. Such an arrangement would hardly seem advantageous against carnivores. However, it has recently been proposed that another reason some animals evolved armor was for protection when fighting other members of the same species. If rival Armadillosuchus commonly attacked each other on the neck and the front of the torso, it would make sense that they evolved greater osteoderm coverage in those regions. Of course, better protection against local predators would have been a much appreciated bonus. In any event, even just the paramedian osteoderms offered a degree of protection, and additional accessory osteoderms have been found belonging to Armadillosuchus. It is unclear where they were located on its body, but it has been suggested they may have protected its limbs or belly, as in a number of other Crocodylomorphs. As another twist, there is recent evidence that the osteoderms of notosuchians may not have even been visible in life. Although Armadillosuchus itself was not included in the study, examination of notosuchian osteoderms found that they may have been covered by a layer of leathery skin. If this extended to Armadillosuchus, then neither the taco-shelled nor accurate reconstructions of its armor represent what the real animal looked like when alive. Overall, most of the osteoderms of Armadillosuchus were simply a more extreme form of the armor seen in crocodilians and most other crocodylomorphs. The cervical shield was a unique innovation, but the rest of the armor had little resemblance to the taco shell reconstructions. In any event, the flawed image created by the overly literal museum model remains the image most people have of the armadillo croc. Another notosuchian, named Simosuchus, did have much more extensive, rigid armor than Armadillosuchus. However, Simosuchus's armor still didn't closely resemble that of armadillos. Distant relatives of the Crocodylomorphs from the Triassic period, called adosaurs, also had a greater resemblance to armadillos. Rather than the rows of osteoderms found in Armadillosuchus, their armor consisted primarily of paramedian osteoderms that had expanded to cover most of their, sometimes very wide, bodies. Although some adosaurs did have a supplemental row of osteoderms, they served as spikes, rather than as a way to increase their armor's coverage. Armadillosuchus's armor may not have even been unique to it, as the osteoderms of the closely related sphagosaurids Caryanosuchus and Sphagosaurus are currently missing. On the other hand, the armor found in the Sphagosaurid genus Caipirasuchus is fairly simple, consisting of the basic paramedian osteoderms on the back. Unusually, in the species Caipirasuchus minoris, the armor appears to be missing from the front. If so, Armadillosuchus might not have been the only Sphagosaurid with conspicuous gaps in its osteoderm coverage. There is much more to Armadillosuchus than its namesake armor. Like many other notosuchians, Armadillosuchus had a short, round skull, although it was longer than those of most other Sphagosaurids. Compared to its relatives, the top of its skull was also flatter and wider, but overall, Armadillosuchus's skull was still deeper than modern crocodilians. Armadillosuchus's teeth bore little resemblance to those of either crocodilians or armadillos. Unfortunately, the taco shell model on display at the Museum of Environment in Rio de Janeiro also poorly represents them, containing only one type of tooth. Like many other notosuchians, the real armadillo croc's teeth were heterodont, coming in multiple shapes. The teeth at the front of the skull were very distinctive. They were a pair of very large, canine-like teeth in the premaxilla, along with one or two smaller pairs. The number of these teeth varies between specimens, which was common among other sphagosaurids. The teeth at the front of the lower jaw were also long and junted forward. Like many other notosuchians, the teeth further back in Armadillosuchus's jaws were more complex. They looked like the short, conical teeth of Crocodilians, but with a ridge lined with small denticles. Their shape and position would have enabled them to make a scissor-like shearing action when chewing, allowing the armadillo croc to efficiently grind its food like in mammals. While some notosuchians, like the Baurusuchids, had simple, flesh-cutting teeth, complex, varied teeth and mammal-like chewing were common within Notosuchia. Indeed, one notosuchian, the Chinese Chimaerosuchus paradoxus, was named for just how mammal-like its teeth were. Unlike mammals, Armadillosuchus replaced its teeth throughout its life. This is common among reptiles, whose teeth are typically simple and fairly interchangeable, but regular tooth replacement presented a challenge for the more specialized intention of the armadillo croc. They were replaced in a coordinated wave pattern, starting front to back. Only odd-numbered or even-numbered teeth would be replaced in a given cycle to avoid compromising their precise occlusion with each other. While its teeth were sophisticated compared to those of most other reptiles, Armadillosuchus's exact diet remains unclear. The authors of the original description considered Armadillosuchus to be an omnivore. Suggested food sources included roots, carcasses that had dried in the desert sun, and mollusks, whose fossils have been found in other parts of the Adamantia Formation. The findings of a later study analyzing the teeth of various extinct crocodylomorphs agreed with this assessment. While its teeth were found to be within the range of both omnivores and insectivores, Armadillosuchus was far larger than most dedicated insectivores. Although the details are still unclear, as of right now, the armadillo croc's diet is thought to have been mostly a mixture of plants and invertebrates. The diets of most other sphagosaurids are even less understood. However, Chimaerosuchus is thought to have primarily eaten plants, while Adamantiasuchus's teeth were better suited for meat or insects. Rocks that may have been gastroless, stones swallowed to aid digestion, have been found associated with one Armadillosuchus specimen. Whatever Armadillosuchus ate, it seems that, much like armadillos, it regularly involved digging. The shape of its skull was well suited for this, and was supported by large muscles. The teeth which jutted out from the lower jaw were worn at the ends. There's little else that could create such wear besides using them to dig through the dirt, which these teeth would have been excellent at. Finally, Armadillosuchus also possessed large hand claws and muscular limbs. Its strong digging capabilities would have been useful when searching for roots or insects. The environment preserved in the Adamantia Formation was semi-arid and highly seasonal. Roots and dried carcasses would have been some of the most common food available during the dry season. Armadillosuchus also likely dug burrows to provide sanctuary from the hot sun. These would have also served as a refuge from carnivores, whether they be dinosaurs such as the belosaurid theropods, or fellow notosuchians like Baurusuchus. Fossils of the latter were actually found in close association with the Armadillosuchus holotype. However, Armadillosuchus would have also needed to spend large amounts of time basking in the sun to warm up. Examination of the bone histology of it and the other notosuchians has found they were ectothermic, or cold-blooded. Ectotherms are reliant on the external environment to maintain their body temperature, unlike endotherms like dinosaurs and mammals, who maintain their own body heat by burning energy. The resulting low metabolism meant that Armadillosuchus would have been less active than either the contemporary dinosaurs or armadillos. Still, it had a higher metabolism than crocodilians and most other modern ectotherms. This allowed notosuchians like Armadillosuchus to be competitive with endotherms like dinosaurs and mammals. While they would have needed copious amounts of food to maintain their body temperatures, Armadillosuchus could have gotten by on far less, a boom in its arid home. In contrast to crocodilians, and indeed most other ectotherms, the limbs of Armadillosuchus and most other notosuchians were held in a straight, erect stance. They were also longer than the limbs of most other reptiles, which would have made them better roamers and runners. These traits were critical for Armadillosuchus in an environment with meager resources throughout much of the year, and which was home to large, meat-eating dinosaurs. This was actually the ancestral state of Crocodylomorpha, and Crocodilians only reverted to a semi-sprawling stance after their last common ancestor with the Notosuchians. A fairly high metabolism was also the ancestral state of Crocodylomorpha, but the shift to an ectothermic metabolism happened earlier in the clade's evolutionary history. As a side note, even though the vaguely bipedal stance of Armadillosuchus in this reconstruction may seem as absurd as its taco shell armor, it isn't. The earliest Crocodylomorphs were capable of bipedal locomotion, and some species may have even been obligate bipeds. Furthermore, footprints from Cretaceous Korea, named Batrachopus grandis, seem to have been made by a crocodylomorph that had returned to a bipedal gait. Given that Armadillosuchus's hind legs are missing, a bipedal posture is possible, if not particularly likely. While it probably walked on 4 legs, and definitely lacked the famous taco shell, Armadillosuchus was certainly weird even by crocodylomorph standards. It modified the basic crocodylomorph set of osteoderms in a unique way, and was a digger well adapted to harsh conditions. Additionally, with a length of 2 meters, the armadillo croc reached a size that was elsewhere uncommon for non-dinosaurs, while its complex teeth echoed those of mammals. On the other hand, Armadillosuchus represents a clear failure in science communication. Skeletal mounts, particularly older ones, don't always make it clear which parts are real fossils, or at least cast of real fossils, and what is speculation used to fill in the gaps. The small holes in the skeletal model's taco shell armor are exceptionally egregious, as they give the false impression that most of its armor is known, when in reality a lot of it is missing, and what has been found has little resemblance to it. This inaccuracy has since been repeated in most paleoart depicting Armadillosuchus, as there are few other resources available for non-specialists to understand what the armadillo croc looked like. It is regrettable that one of the most famous land crocs, which are already an unduly obscure group, is so often misrepresented. Hopefully, such misunderstandings will be corrected, and more people will learn about the real Armadillosuchus. Thank you for watching, and a thank you to my supporters on Patreon. If you enjoyed this video, please remember to hit the like button, and consider subscribing if you would like to see more. If you'd like to support this channel more directly, you can join my Patreon, where you'll have access to polls to select the topics of future videos. Finally, be sure to have a great day.